Overview of data analyst ecosystem. The data analyst ecosystem includes the infrastructure, software, tools, frameworks, and processes used to gather, clean, analyze, mine, and visualize data. In this part, we will go over a quick overview of the ecosystem before going into the detail of each of these topics in subsequent portion of the lecture. Let's first talk about data. Based on how well defined the structure of the data is, data can be categorized as structured, semi-structured, and unstructured. Data that follows a rigid format and can be organized neatly into rows and columns is structured data. This data that you see typically is a database and a spreadsheet. For example, semi-structured data is a mix of data that has consistent characteristics and data that doesn't conform into a rigid structure. For example, emails. An email has a mix of structured data such as the name of the sender and recipient, but also has the content of the email, which is unstructured data. And then there is a unstructured data that is complex and mostly qualitative information that is impossible to reduce to rows and columns. For example, photos, videos, text files, PDF, and social media content. Type of data drives the kind of repository that the data can be collected and stored in, and also the tools that can be used to query and process data. Data also comes in wide ranging variety of file formats being collected from variety of data sources ranging from relational and non-relational databases to APIs, web services, data streams, social platforms, and sensor devices. To bring us to the data repositories, a term that includes databases, data warehouses, data marts, data lakes, and big data stores. The type, format, and source of data influences the type of data repositories that you can use to collect, store, clean, analyze, and mine the data for analysis. If you are working with big data, for example, you will need big data warehouses that allows you to store and process large volume, high velocity data, and also frameworks that allow you to perform complex analytics in real time in big data. The ecosystem also includes languages that can be classified as query languages, programming languages, and shell and scripting languages. From querying and manipulating data with SQL to developing data applications with Python and writing shell scripts for repetitive operational tasks. These are important components in a data analyst workbench. Automated tools, frameworks, and processes for all stages of analytics processes are part of data analyst ecosystem. From tools used for gathering, extracting, transforming, and loading data into repositories to tools for data wrangling, data cleaning, data mining, data analysis, and data visualization. It's a very diverse and rich ecosystem. Spreadsheets, Jupyter notebooks, and IBM Cognos are just a few examples. We will cover some of the data analytics tools in greater detail in subsequent part of this lecture. Next, types of data. Data is unorganized information that is processed to make it meaningful. Generally, data comprises of facts, observations, perceptions, numbers, characters, symbols, and images that can be interpreted to derive meaning. One of the way in which data can be categorized is by its structure. Data can be structured, semi-structured, and unstructured. Structured data has a well-defined structure or adheres to a specific data model that can be stored in well-defined schemas such as databases and in many cases can be represented in a tabular manner with rows and columns. Structured data is objective facts and numbers that can be collected, exported, stored, and organized in typical databases. Some of the sources of structured data could be SQL databases and online transaction processing, also called as OLTP systems that focuses on business transactions, spreadsheets such as Excel and Google spreadsheets, online forms, sensors such as global positioning systems or GPS, and radio frequency identification, also called as RFID tags, and network and web server logs. You can typically store structured data in a relational or SQL database, SQL. You can also easily examine structured data with standard data analysis methods and tools. Semi-structured data is data that has some organizational properties but lacks a fixed or rigid schema. Semi-structured data cannot be stored in forms of rows and columns as in a database. It contains tags and elements or metadata, which is used to group data and organize it in a hierarchy. Some of the sources of semi-structured data could be emails, XML, and other markup languages, binary executables, TCP, IP packets, zip files, integration of data from different sources. XML and JSON allow users to define tags and attributes to store data in a hierarchical form and are used widely to store and exchange semi-structured data. Unstructured data is data that does not have any easily identifiable structure and therefore cannot be organized in a mainstream relational database in the form of rows and columns. It does not follow any particular format, sequence, semantics, or rules. Unstructured data can deal with heterogeneity of sources and has a variety of business intelligence and analytics applications. Some of the sources of unstructured data could be web pages, social media feeds, images in varied file formats such as JPEG, GIF, and PNG, video and audio files, documents and PDF files, PowerPoint presentations, media logs, and surveys. Unstructured data can be stored in files and documentations such as Word doc for manual analysis or in NoSQL database that have their own analysis tools for examining this type of data. To summarize, structured data is data that is well organized in formats that can be stored in databases and lends itself to standard data analysis methods and tools. Semi-structured data is data that is somewhat organized and relies on meta tags for grouping and hierarchy, and unstructured data is data that is not conventionally organized in form of rows and columns in a particular format. In the next part, we'll be learning more about different types of file structures. As a data professional, you will be working with a variety of data files and formats. It is important to understand the underlying structure of file formats along with their benefits and limitations. This understanding will support you to make the right decision on the formats best suited for your data and performance needs. Some of the standard file formats that we will cover in this part include delimited text file format, Microsoft Excel Open XML spreadsheet, or XLSX Extensible Markup Language or XML, portable document format or PDF, JavaScript Object Notation or JSON, delimited text file or text files used to store data as text in which each line or row has value separated by a delimiter. Where a delimiter is a sequence of one or more characters for specifying the boundary between independent entities or values. Any character can be used to separate the values, but most common delimiter are comma, colon, vertical bar, and space. Comma separated values or CSVs and tab separated values or TSVs are the most commonly used file types in this category. In CSV, the delimiter is a comma, while in TSV the delimiter is a tab. When literal commas are present in text data and therefore cannot be used as delimiters, TSV serve as the alternative to CSV format. Tab stops are infrequent in running text. Each row or horizontal line in the text file has a set of values separated by a delimiter and represents a record. The first row, that is the top row, works as a column header where each column can have a different type of data. For example, a column can have a date type while another can have a string or integer type data. Delimited files allow field values of any length and are considered as a standard format for providing straightforward information schema. They can be processed by almost all existing applications. Delimiters also represent one of the various means to specify boundaries in a data stream. Microsoft Excel Open XML spreadsheet or XLXX is a Microsoft Excel Open XML file format that falls under the spreadsheet file format. It is an XML based file format that falls under spreadsheet file format. It is an XML based file format created by Microsoft. In an XLSX, also known as workbook, there can be multiple sheets and each worksheet is organized into rows, into rows and columns. Horizontal are rows, verticals are columns, and at the intersection of each is a cell. Each cell contains data. XLSX uses open file format, which means it generally is accessible to most other applications. It can use and save all functions available in Excel and is also known to be one of the more secure file formats, as it cannot save malicious code. Extensible markup language or XLM is a markup language with set rules for encoding data. The XML file format is both readable by humans and machines. It is self-descriptive language designed for sending information over the internet. XML is similar to HTML in some respects, but also has differences. For example, XML does not use predefined tags like HTML does. XML is platform independent and program language independent, therefore simplifies data sharing between various systems. The next, portable document format or PDF is a file format developed by Adobe to present document independent of application software, hardware and operating system, which means it can be viewed the same way on any device. This format is frequently used in legal and financial document and can also be used to fill in data such as forms. JavaScript Object Notation or JSON is a text-based open standard design for transmitting structured data over the web. The file format is a language independent data format that can be read in any programming language. JSON is easy to use is compatible with wide range of browsers and is considered as one of the best tools for sharing of any size and type, even audio and video. That is one reason many APIs and web services return data as JSON. In this part, we looked at some popular file and data format. In the next part, we will be learning about different sources of data. Data sources have never been as dynamic and diverse as they are today. In this part, we will look at some of the common sources such as relational databases, flat files, and XML datasets, API and web services, web scraping, data streams and feeds. Typically, organizations have internal applications to support them in managing their day-to-day business activities, customer transactions, human resource activities, and their workflows. These systems use relational databases such as SQL Server, Oracle, MySQL, and IBM DB2 to store data in a structured way. Data stored in databases and data warehouses can be used as a source for analysis. For example, data from a retail transaction system can be used to analyze sales in different regions, and data from a customer relationship management system can be used for making sales projections. External to organization, there are other publicly and privately available data sets. For example, government organizations releasing demographic and economic data set on an ongoing basis. Then there are companies that sell specific data, for example, point of sale data or financial data or weather data, which businesses can use to define strategy, predict demand, and make decisions related to distribution or marketing promotions, among other things. Such data sets are typically made available as a flat files, spreadsheet files, and XML documents. Flat files, they store data in plain text format with one record or row per line and each value separated by delimiters such as comma, semicolon, and tabs. Data in a flat file maps to a single table, unlike relational databases that contain multiple tables. One of the most common flat file format is CSV, in which values are separated by commas. Spreadsheet files are a special type of flat files that also organize data in a tabular format, rows, columns, but a spreadsheet can contain multiple worksheets as well. And each worksheet can map a different table. Although data in spreadsheet is a plain text, the files can be stored in a custom formats and include additional information such as formatting formulas, etc. Microsoft Excel, which stores data in XLX or XLSX format, is probably the most common use spreadsheet. Other common spreadsheets include Google Sheets, Apple Numbers, and LibreOffice. Next, XML files contain data values that are identified or marked up using tags, while data in flat files is flat or maps to a single table. XML files can support more complex data structures such as hierarchical. Some common uses of XML files can support more complex data structures such as hierarchical. Some commonly uses are from online surveys, bank statements, and other unstructured data sets. Many data providers and websites provide APIs or application programming interfaces and web services which multiple users or applications can interact with and obtain data for processes and analysis. APIs and web services typically listen to for incoming requests, which can be in a form of web requests from users or network requests from applications, and return data in plain text, XML, HTML, JSON, or media files. Let's talk at some popular example of APIs being used as a data source for data analytics. The use of Twitter and Facebook APIs to source data from tweets and posts from performing tasks such as opinion mining or sentiment analysis, which is to summarize the amount of appreciation and criticism on a given subject, such as policies of government and product, service, or customer satisfaction in general. Next, stock market APIs used for pulling data such as share and commodity prices, earning per share, and historical prices for training and analysis. Data lookup and validation APIs, which can be very helpful for data analysts for cleaning and data preparation, as well as for correlating data, for example, to check which city or state a postal or a zip code belong to. APIs are also used for pulling data from database sources within an external to organization source as well. Web scraping is used to extract relevant data from unstructured sources, also known as screen scraping. Web harvesting and web data extraction. Web scraping makes it possible to download specific data from web pages based on defined parameters. Web scrapers can, among other things, extract text, contact information, images, videos, product items, and much more from a website. Some popular uses of web scraping include collecting product detail from retailers, manufacturers, and e-commerce websites to provide price comparisons, generating sales leads through public data source, extracting data from posts and authors on various forums and communities, and collection, training, and testing datasets for machine learning models. Some of the popular web scraping tools include Beautiful Soup, Scrapy, Pandas, and Seleniums. Data streams are another widely used source for aggregating constant stream of data flowing from sources such as instruments, IoT devices, that is Internet of Things devices and applications, GPS data, global positioning system data from cars, computer programs, website, and social media posts. This data is generally time-stamped and also geotagged for geographical identification. Some of the data streams and ways in which they can be leveraged include stock and market ticker for financial trading, retail transactions streams for predicting demand and supply chain management, surveillance and video feeds for threat detection, social media feeds for sentiment analysis, sensor data feeds for monitoring industrial or farming machinery, web click feed for monitoring web performance and improving design, and real-time flight event for rebooking and rescheduling. Some popular applications used to process data streams include Apache Kafka, Apache Spark Streaming, and Apache Storm. Next, RSS or really simple syndication feeds are another popular data source. These are typically used for capturing updated data from online forums and news sites where data is refreshed on an ongoing basis using a feed reader, which is an interface that converts RSS text files into stream of updated data. Updates are streamed to user devices.
In this video, we will listen to several data professionals talk about their experience of working with varied data sources and types of data.
So you'd be surprised the different ways that data can come at you. I tend to be a relational database fan, and so I spend a lot of time with SQL. And using the power of SQL to deal with moving data from one place to another, to deal with structuring of data, to deal with all the security details around data. But obviously, that doesn't apply to every scenario, and even when we're dealing entirely in relational databases, we're often moving data from one relational database to another, and especially when we're talking about one vendor to another, that can be challenging. The things that also get in the way tend to be the versioning. So sometimes the feature of something that you want is in a version 2 levels above where you are, or it doesn't work the same way as it did 2 versions ago. So working with multiple data sources is about flexibility. It's about finding the function that works and works with the performance you need. Moving data one time is usually not all that hard as long as we're sub-terabyte, but moving data consistently and continually and in a performant way can cause us to evaluate a lot of different solutions. So we really need to be open to new ideas and looking for new solutions that meet the requirements that we have.
Mostly I work with relational databases. They're extremely flexible and withstood the test of time. However, with the evolution of unstructured data such as logs, documents, XML, and JSON, their reputation as a cure for all of your data problems came under intense scrutiny, and most of data-intensive applications such as IoT and social media applications started to look elsewhere. For example, Google released a white paper back in 2006 called Google Big Table, and that idea quickly caught fire. For example, Cassandra and HBase came out of the same architectural model as the Google Big Table, and they became widely popular databases to solve some of the problems that relational databases fail to solve. For example, relational databases struggle a little bit with heavy write-intensive applications such as IoT or sensor data or social media data, because the B-tree data structures that drive or power these relational databases slows down due to their nature of the random reads and random writes for the heavy write applications.
It's an inevitable part of a data engineer's job to work with a variety of data. You will need to work with standard formats like CSV, JSON, XML, but also you'll need to work with proprietary formats. And you will need to get data in different sources, whether it be relational databases, NoSQL, or big data repositories. You will need to work with data at rest, streaming data or data in motion, and you might not have the skills to work with all of these different types of data sources from day one, but you need to be able to learn as you go and pick up these skills required for the project to work with different data sets, different data formats, and different data sources.
When it comes to the data formats, log data, XML data, JSON, etc., each of them comes with their own challenges. For example, log data is extremely challenging because it's unstructured, and you may need to write your own custom tools to parse the data depending on what you want to look at. Whereas XML was widely popular like a decade ago, especially with the SOAP protocol of the web applications. However, soon the web developers and the corporations discovered that it can be resource intensive, especially memory, because it has both the starting and ending tags. So then JSON came into the picture. They got rid of the ending tags and they looked like a key value pairs, and it saved some resources, and it is now widely used as part of the RESTful APIs, and then even newer versions of the data formats such as Apache Avro were gaining a wide popularity because of the efficiency on how they store the data.
One particular situation where we were converting data from a DB2 database into a SQL Server database, and it was challenging because the way that each of those expect imports and exports to happen is a little bit different. The data was particularly challenging, and that's where a lot of your challenge might come from in these projects, is from the data itself. In this particular case, the data had a lot of different characters in it, so usually we're looking for a character we can use as a delimiter. Oftentimes that's comma delimited, so we can separate our fields using commas. But we also have to think about situations where we have data that has commas in it. How do we properly separate that data? How do we properly define our fields? And in this particular case, we had to use different separators for different tables because every single special character that we could think of was in one of those tables. And the special characters that weren't were sometimes ones we couldn't use for separation, such as the bell character.
Next, metadata and metadata management. It's a reading assignment for you guys. So please go ahead and read this, all these slides that contains objectives, what is metadata, the basic description, then technical metadata, followed by process metadata, business metadata, managing them, why is metadata management so important, and finally the popular tools for metadata management and summary for the same. Finally, we have a summary slide for the entire lecture. Please read, understand the content of all these slides from slide number 58 until 62. Eventually, we will be having a quiz at the end of this class. Again, it's a virtual quiz. We'll be using Canvas, and all the questions will be asked from the lecture as well as these last 5 slides. So thank you so much, guys, for your time, attention. Have a very nice day. Bye-bye.